Hi everybody and welcome. Today Clover and I are coming at you talking about sums of arithmetic and geometric sequences. So the goal for today's video is going to be to basically take a series of numbers, let's say something like 1 to 2 to 3, going all the way on to 10, and saying if we took all of these things and added them together, so again going all the way up to that final number, what is the sum? So what is that answer? That's kind of the goal for today. So this is pretty useful in quite a bit of ways. It's kind of like, I'd say the best example is, you start a text chain, you send it to 5 people, each one of those 5 people sends it to another 5 people, and so on and so on and so on. We're adding up each of those as they go. So instead of just knowing how many people send it on the 5th step, it's not only how many people sent it on the 5th step, but adding together everyone that sent it so far. So adding step 1 to step 2 to step 3 to step 4 to step 5. So actually a pretty useful life skill here today, and something that just honestly saves you quite a bit of time, just like adding things a lot together into a calculator. So a few things to remember from last video. Our formula for an arithmetic sequence term, so any given term, is the following. So this is term n. This is our first term. N is just n, and then d is our common difference. For geometric, similar formula, starting off with term n, using our term a subscript 1, or our first term again. This time r is our common ratio, and then it's to the n minus 1 power. So again, term n in a sequence, like if it's term 10, for example, and then first one. And then now our common ratio is what we divide by. So that's Clover and me giving you some review from 9.1 in case you forgot those formulas. So what's the deal for today? So how are we going to kind of break this up? So let's start off with arithmetic sums. For this, we have a formula that we're going to use, and it's actually very similar to what we have up top. So what we do is we now introduce something new on the outside, so n minus 2. We multiply our first term times 2, but otherwise, it's exactly the same. And Clover's got a lot to say today, so if you hear in the background, sorry about that. So again, it's exactly the same as what we see up here. We're just adding in 2 new things. So what's in green is new, and again, remember that we have parentheses, so don't forget about those, and what's in yellow is what we had before. So this tells us the sum of a sequence. So let's go over an example of an arithmetic sum. So let's say we have the sequence 12, 19, 26, and then they do that annoying ... thing. They say it keeps going until you get to 180, and they want to know what the sum of this is. So that would be really annoying to type into your calculator. It would probably take you about 5 minutes. You'd probably miss one of the numbers or type it in wrong, and you get the whole thing wrong, even though you just spent all that time. So what do we do? Well, first things, let's start off with what we know. We know our first term is 12. We know if we go from here to here, that's 7. From here to here, that's 7. So we have that common difference of 7. And we also know that our a to the n term, we don't know which term this is in the sequence, but we know that it's 180. So we have a few things that we can use to kind of help us to get started here. So let's start off with actually our formula from 9.1. A to the n equals our first term plus n minus 1 times our difference. So we have a few of these things that we can plug in, but we don't know what n is this time, and that's maybe a little bit new here. Okay, so take this one step at a time, distribute our 7 in. We can put together some like terms here. So the 12 minus 7 is 5, plus 7n equals 180. Subtract 5. So we got 175 equals 7n. we can divide both of these by 7 here. So now we'll have 175 divided by 7. So n equals 25. So we know that this is our 25th term. So that's what that n tells us. So now we can go back to the new formula from today, so our 9.2 formula, and plug in what we know. So now we know that n is 25. Sorry for Clover in the background there. We know that our first term has not changed. It's still 12. We know n is 25 now, and our common difference is still 7. So working through this, we'll get 12.5, 24 plus 24 times 7. Basically just working through PEMDAS here to finish up. To get that final answer of 2,400. So the sum from our first term all the way to that last term is 2,400. So a heck of a lot better than punching those into your calculator, and also a whole lot more accurate, because instead of guessing or accidentally punching in the wrong number, we know that when we do this here, this is it. This is the formula that works. So a little bit of practice here. Again, 9.1 review is here, so this is from last Wednesday. But if we're looking at our new formula here, this is basically just plugging in the old formula and adding 2 extra steps. So still mostly just relying on our calculators today to do a lot of this for us, but making sure that we plug in PEMDAS correctly, we're plugging in the right things for where they belong. Next, we have a very similar concept that works as well for geometric sequences. So instead of adding or subtracting to increase, this time we're looking at it for multiplying or dividing. So our formula for this one, and there's actually 2, depends on what you're given for geometric. So in this case, r is our common ratio, so what we're multiplying or dividing by. And 8 of the 1 is still just the first term. So that's one option. So if you're given those 2 things, use that formula. There's a second formula that works equally as well, just uses some different things. In this case, r is our common ratio. We still have our first term. And then now, that's basically what we have there. So in this case, we wouldn't know what n is as well. So again, just depending on what you have to fill in here. So here we know n, so we know the number of terms in the sequence. And in this case, the second one, we don't know n. So we still have some common things that we know in both of these, but it just kind of depends on what information we do and don't have. Here we have this term, we have the nth term. So again, these are the 3 variables for the second formula. These are the 3 variables for our first formula. And depending on, basically which set of numbers we have is going to determine which ones we use. So let's go over some examples. So example number 1. Let's say here they give us that r equals 5 and that n equals 8. So, and we're trying to find our 8th term in this one. And I think we're missing one thing. So let me take a quick look back and make sure that we have this full question for us here. So starting based off of this though, it looks like because we know n, we're definitely going to be using that first formula. So we can get started with that here. based off the information that we're given. So a to the 1 minus a to the 1 r to the n power over 1 minus r. So again, because we have an n term, we're going to have to use that first formula. I think we're missing one piece of information on this question that I forgot to write down. So again, I'm just pulling that out here, and then we can go from there. And sorry about the delay, friends. Here it is. So we have r is 5, and the thing that we're missing here, that's why I wrote it down wrong. A to the 1 is also 5. Or our first term is also 5. So with that information, now we're ready to keep rolling and keep moving through here. So basically, just like we've been doing for so much of this, we're going to plug in everything that we know. So here we want our 8th term, and we're plugging in one step at a time the things that we know. So our first term is 5, so we're going to plug that in. We know our r value is 5. We're looking for n to the 8th. And again, our r value is still 5. So a lot of things we're just kind of plugging in one step at a time here. So the sum of terms 1 through 8 is 1 minus 5 times 5 to the 8th power. So we got to punch that one into a calculator. Over -4. Our next step is take what we had on top there and multiply that by 5. Again, all over -4 still. And now it's 5 minus that. Again, -156,2495 over -4. Always good to go through and make sure that we got these here. Okay, so let's see. So 5, 8, punch all these in. Oh, you know what? It looks like we might have made a mistake here. Hold on. Go back one step. Here we go. This is better. 195, 3125. So now we'll have 195, 3120. Divide that by 4. And then that will fully simplify here to 488,280. And that's going to be our sum of terms 1 through 8. So again, as you can see there from that example, it's really hard punching in these big numbers. So take your time and make sure that you go back and double check. And that way you'll avoid making a mistake. And even if you do, if you double check, you'll go back and you'll be able to fix it there. So just to recap, the big point of today is let's make sure that we can plug in those values. So here n is 8, we plug that one in. R is 5, so we plug in 5 everywhere that we see an R. We had our first term is 5 as well, so we plug in a 5 everywhere that we see that first term. After that, we're just doing some PEMDAS. So doing our exponents first, multiplying next, basically going in order until we fully simplify and get to the final answer that we're looking for there. There's one other example that we can do that will probably help clear these things up a little bit more. So this time we have a to the 1, or our first term is 16. Our common ratio is 2, and we're looking for the sum of our 8th term. So our formula here that we're going to be using is as follows. So again, taking these things, plugging them in where we see them. And that's going to allow us to successfully evaluate. And we have to type in 2 to the 8th power here. Multiply that by 16. And then both of those negatives will cancel to get us just 4,080. So our 8th term is 4,080. So again, I say this is mostly an exercise of plugging into a formula and then using PEMDAS second, but I think the key is